a restaurant, added items to your cart, paid for your order, watched the delivery person move toward you on a map in real time, and then received a notification the moment your food arrived. All of that happened in seconds. And behind every single one of those steps, the search, the cart, the payment, the map, the notification, there is a separate, independent piece of software quietly doing its job. That is microservices architecture at work. And once you understand how it works, you will start to see it everywhere. In the apps you use every day, in the companies that power the modern internet, and in some of the most impressive engineering decisions made in the last 2 decades. In this video, we're going to break down microservices architecture from the very beginning. No prior technical knowledge required. We will cover what it is, how it works, why it exists, how real companies like Netflix, Amazon, and Uber use it today, and what its genuine challenges are. Are a student exploring software development, an IT professional looking to deepen your knowledge, or simply someone curious about how the technology around you actually works? This video is built for you. Let us begin. To understand microservices, we first need to understand what came before it and why it stopped working. Imagine a company builds a brand new web application. It is a shopping platform. The application handles everything: browsing products, managing user accounts, adding items to a cart, processing payments, and tracking orders. All of this lives inside one single system, written as one large piece of software. This is called a monolithic application. Think of it like a large department store where every department, clothing, electronics, food, furniture, is all packed into one massive room with no walls or dividers between them. Everything shares the same space, the same resources, and the same exit door. In the beginning, this approach works perfectly well. The team is small. The application is manageable. Everything is in one place, which makes it easier to build and test. But then the company starts growing. Thousands of users become hundreds of thousands, then millions. New features are needed every week. The team expands from 10 engineers to 100, and this is where the problems begin. Because everything is connected to everything else inside the monolith, changing one small feature can break something completely different. The payment system and the product search are not separate. They are part of the same large machine. Touch one gear, and you risk stopping the whole mechanism. Deploying a small update means the entire application has to be rebuilt and restarted from scratch, even if only 2 lines of code changed. That means potential downtime, and downtime means lost revenue and frustrated customers. And when traffic spikes, say during a big sale event, the only option is to scale up the entire application, even if only the payment processing system is under pressure. You cannot scale just the payment system. You have to scale everything, all at once. That is expensive and inefficient. The teams get in each other's way. The system becomes harder and harder to understand. And eventually, the company realizes they are spending more time managing the complexity of the old system than they are building new things. Something has to change. The answer that the technology world arrived at is called microservices architecture. The idea is straightforward. Instead of building one large application that does everything, you break the application into many small, independent pieces, each one responsible for one specific job. Each piece is what we call a microservice. Going back to our shopping platform example, instead of one monolithic system, you now have separate services. One service handles user accounts and logins. A completely separate service handles the product catalog. Another service manages the shopping cart. Another handles payments. Another tracks orders. Another sends notifications. Each of these services lives on its own. It has its own code. It can be built, tested, updated, and deployed completely independently of all the others. If you want to improve the payment system, you update just the payment service. Nothing else is touched. Nothing else is at risk. And here is what makes this truly powerful. These services communicate with each other by sending messages back and forth, the same way people send text messages. Each service does not need to know how the other services work on the inside. It only needs to know how to send a request and receive a response. The result is a system that is flexible, scalable, and resilient, one where a problem in one service does not bring down the entire application. and where teams can work on different services simultaneously without stepping on each other's toes. That is the core idea of microservices architecture. Let us bring this to life with an analogy that most people can relate to. An international airport. A major airport does not have one person or even one department doing everything. There is a dedicated check-in team, a separate security team, a passport control team, a boarding gate team, a baggage handling team, a team managing the runways, a customs team. Each of these is a specialized group focused on one job, operating independently. When the security team needs to update their scanning procedures, they do not need to consult the check-in team or the baggage handlers. They update their own process and carry on. The rest of the airport keeps running. If the baggage handling team is overwhelmed because 3 large flights landed at the same time, the airport can bring in more baggage handlers without touching any other part of the operation. The security team does not get doubled just because baggage is backed up. And critically, if the check-in system experiences a problem and slows down, the plane can still be refueled, the runways can still be managed, and the airport keeps functioning. One team having a bad day does not shut down the whole airport. That is exactly how microservices work. Each service is like a specialized team, focused on its own function, able to grow or shrink independently, and isolated enough that problems do not cascade across the entire system. Now, you might be wondering, if all these services are separate, how do they work together to deliver one smooth experience to the user? The answer is communication, and there are 2 primary ways services talk to each other. The first is a direct, real-time conversation. When a user adds something to their shopping cart, the cart service needs to immediately check with the product catalog service to confirm the item is available. This happens instantly, back and forth, in real time. Think of it like a phone call. One service dials another, gets an answer, and acts on it. The second is a message-based approach. Instead of waiting for an immediate reply, a service sends a message to a shared mailbox, and other services pick up that message when they are ready. For example, when an order is placed, the order service drops a message into the mailbox saying a new order has arrived. The notification service picks that up and sends the customer a confirmation. The inventory service picks it up and updates the stock levels. Both happen independently, without either service needing to be directly connected to the order service. Think of it like sending an email. You send it, and the recipients respond in their own time. There is also a component that sits at the front of the entire system, called a gateway. Think of it as the main reception desk. Every request from a user, whether they are on a phone, a laptop, or a tablet, first arrives at this gateway. The gateway then figures out which service or services need to be involved, routes the request to the right places, and assembles the response before sending it back to the user. From the user's point of view, they just see one smooth, unified application. They have no idea that dozens of separate services are working together behind the scenes to deliver that experience. Let us walk through a complete concrete example to make all of this click. Imagine you open a food delivery app called QuickBite. You search for pizza restaurants near you. You choose a restaurant. You add 2 pizzas to your cart. You apply a discount code. You pay. You watch the delivery driver's location on the map. And 25 minutes later, you receive a notification that your food has arrived. That single experience, from start to finish, involved multiple independent services working in sequence. When you searched for pizza restaurants, the search service handled that. It looked up nearby restaurants, ranked them by rating and distance, and returned the results to your screen. When you tapped on a restaurant and saw its menu, the restaurant service provided that information. The menu items, prices, photos, and descriptions. When you added pizzas to your cart, the cart service managed that. It kept track of what you added, calculated the total, and held that information while you browsed. When you applied a discount code, the promotion service validated it, checking whether the code was real, whether it applied to your order, and how much to deduct. When you paid, the payment service took over. It communicated with your bank, processed the transaction, and confirmed the payment. The moment your payment was confirmed, the order service created your order and notified the restaurant. Simultaneously, the notification service sent you a confirmation message. As the delivery driver picked up your order and started moving, the location service tracked their position in real time and sent updates to your screen. And when your food arrived, the notification service sent the final message to your phone. 8 different services. One seamless experience, each one doing exactly its job, nothing more and nothing less. If the promotion service had a problem that day, discount codes might not work, but the rest of the app would be completely unaffected. You could still search, order, pay, and track your delivery without any issue. That is the practical power of microservices architecture. Now let us look at how some of the most well-known companies in the world have applied this approach, starting with Netflix. Netflix launched in 1997 as a DVD by mail service. When they moved into online video streaming in 2007, they built their streaming platform as a single, large monolithic application running on their own servers. For a while, it worked, but then growth exploded. More subscribers, more countries, more devices, more content. And in August 2008, disaster struck. A major database failure caused a complete outage that lasted 3 days. Millions of customers could not access the service. That failure was a turning point. Netflix engineers recognized that their monolithic architecture was a single point of vulnerability. One problem anywhere in the system could bring everything down simultaneously. They needed to change how they built software. Fundamentally, so Netflix began one of the most ambitious engineering transformations in the history of the technology industry. They migrated their entire platform to cloud infrastructure and rebuilt it from the ground up as a microservices architecture. The process took around 7 years to complete. Today, Netflix operates over 700 individual microservices. One service manages what you have already watched, another handles your monthly subscription payment, another analyzes your viewing history and generates recommendations, another encodes video files into the right format for your screen and your internet connection. Another manages the login process, another handles search. Each of these services runs independently. If the recommendation service has an issue, your recommendations might not load perfectly, but you can still log in, search, and press play. The failure is contained. The rest of the experience continues. Netflix also uses a practice called chaos engineering, where they intentionally introduce failures into their own systems during working hours to test how resilient the architecture is. If one service fails in a controlled test, they want to observe how the system behaves and improve it before a real failure happens. This level of confidence and fault tolerance is only possible because of the way microservices isolate each function from the rest. Today, Netflix serves over 260 million subscribers across more than 190 countries, handling billions of streaming requests every single day, all powered by this microservices architecture. Amazon's story is equally instructive. In its early years, Amazon was built as a single monolithic application. As the company expanded from an online bookstore into the world's largest marketplace, that single application became a serious obstacle. Too many teams, too much code, too many dependencies. A change in the checkout process could affect the product search. An update to the inventory system could ripple into the payment flow. Moving fast was becoming impossible. Around the early 2000s, Amazon made a decision that would define the company's engineering culture for decades. They would break the monolith apart completely into small, independent services. Every function of Amazon's platform, product catalog, shopping cart, checkout, inventory, customer reviews, recommendations, seller tools, became its own independently managed service. Teams at Amazon were reorganized to match this new structure. Each small team owned one or more services. They were responsible for building it, running it, and improving it end to end. Jeff Bezos famously issued a mandate that every team must expose their services capabilities through a well-defined interface, and that teams were not allowed to communicate with each other's services in any other way. If you needed data from another service, you used its published interface, full stop. This restructuring was not just a technical change, it was a cultural one. It gave teams the autonomy and the accountability to move quickly, make decisions, and ship improvements without waiting for approvals from other teams. The results speak for themselves. Amazon's engineering teams can now deploy changes thousands of times per day across the entire platform. Each deployment is small, contained, and tested independently. A new feature for Amazon's recommendation engine does not require coordination with the team managing the payment system. They operate on entirely separate tracks. This architecture is also the foundation on which Amazon Web Services was built, the cloud computing platform that today powers a large share of the internet. The experience Amazon gained from building and running thousands of independent services gave them the knowledge to offer those same capabilities to the rest of the world. Uber offers a third perspective, one that shows how microservices architecture is not just for established giants, but for fast-growing companies navigating explosive scale. Uber started in San Francisco with a single Python application. That one application handled everything: matching riders to drivers, calculating fares, processing payments, sending notifications, and managing accounts. For a startup getting off the ground, this was the right choice. Simple, fast to build, and easy to reason about. But as Uber expanded across cities, countries, and continents, and as it added new products like food delivery and freight, the monolithic application became a serious liability. Scaling the entire system for one city's surge and ride requests meant scaling everything globally. A bug in the fare calculation logic could break the payment flow in every city simultaneously. Adding new features meant navigating a codebase that had grown too large and too tangled for any single team to fully understand. Uber made the decision to break the monolith apart. They decomposed the single application into hundreds of independent services. Ride matching became its own service. Fare calculation became its own service. Driver management, payment processing, notifications, maps, and pricing each became independently operated systems. This meant that when demand for rides surged in one city, Uber could scale just the ride matching service for that region without affecting anything else running globally. When the food delivery product needed new features, the team working on it could deploy independently without coordinating with the team managing driver GPS tracking. The transformation gave Uber the speed and flexibility to operate as a global platform serving tens of millions of trips every day across hundreds of cities, while still being able to ship updates and new features continuously. Having looked at 3 major companies that use microservices, let us now clearly summarize the key benefits this approach delivers. The first benefit is independent scaling. With a monolith, if one part of your application is under heavy load, you have to scale everything. With microservices, you scale only the service that needs it. If your payment service is processing a surge in transactions during a sale, you scale just the payment service. The search service, the cart service, and everything else continues running at its normal capacity. This is more efficient and significantly cheaper. The second benefit is fault isolation. If one service fails, the failure does not automatically bring down the entire system. The problem is contained within that service. The rest of the application continues running. This makes the overall system far more reliable and easier to recover from. The third benefit is faster development and deployment. Different teams can work on different services simultaneously, completely independently. There is no need to coordinate a single giant release. The team responsible for recommendations can ship an update today. The team responsible for payments can ship a different update tomorrow. Each deployment is small and low risk. The fourth benefit is technology flexibility. In a monolith, everyone is locked into the same programming language and the same technical tools. With microservices, each service can be built with whatever technology is best suited for its specific job. A service that requires very fast mathematical calculations might be written in one language, while a service that handles database queries might use a completely different one. The fifth benefit is team autonomy. When a team owns a service from end to end, they take full responsibility for it. They understand it deeply, they improve it continuously, and they make decisions without waiting for approvals from teams working on completely different parts of the system. This creates faster, more confident engineering cultures. Microservices architecture is powerful, but it would be dishonest not to acknowledge the genuine challenges that come with it. The first challenge is complexity. A monolithic application, however large, is one system. Microservices can mean hundreds of systems. Deploying, monitoring, and managing hundreds of independent services requires significantly more sophisticated tooling and processes than managing a single application, The second challenge is communication overhead. When all the code lives in one place, sharing data between different parts of the application is instant. With microservices, every interaction between services involves a network call, sending a message from one service to another over the internet. These calls take time and can fail. Engineers need to design for these failures and handle them gracefully. The third challenge is data management. In a monolith, all parts of the application typically share one database. In a microservices architecture, each service ideally manages its own data store. This means that keeping information consistent across multiple services, ensuring that what the order service knows about a customer matches what the account service knows, requires careful design and ongoing discipline. The fourth challenge is testing. Testing one large application is complex enough. Testing dozens of services that interact with each other requires a much more sophisticated testing strategy. You need to test each service individually and also test how services behave together. The fifth challenge is that microservices are not always the right answer. For a small team building a new product, the overhead of managing many independent services can slow things down considerably. Many companies build a monolith first, moving fast and shipping quickly, and only migrate to microservices once the complexity of the application and the size of the team genuinely justify it. Understanding these challenges is not a reason to avoid microservices. It is a reason to approach them thoughtfully. So how do you decide whether microservices architecture is the right choice for a given situation? Choose microservices when your application has grown large enough that different parts of it genuinely need to be scaled, deployed, and managed independently. Choose them when you have multiple teams that need to work on the same product simultaneously without constantly blocking each other. Choose them when reliability is a top priority, when your business cannot afford for a failure in one feature to bring down the entire experience for every user. On the other hand, start with a monolith when you are a small team building a new idea and speed to market matters more than scalability. Start with a monolith when your team does not yet have the experience and tooling to manage a distributed system. It is far easier to break a well-built monolith into services later than to build microservices prematurely and struggle with their complexity before your business has even found its footing. The most successful organizations treat this as a spectrum, not a binary choice. They start simple, grow deliberately, and move to a more distributed architecture only when the size, scale, and complexity of their product makes it genuinely necessary. Let us bring everything together. A monolithic application puts all functionality into one single system. It is simple to start with, but becomes difficult to scale, change, and manage as it grows. Microservices architecture breaks an application into many small, independent services, each responsible for one specific job. Each service can be built, deployed, and scaled on its own without affecting the others. Services communicate with each other by exchanging messages, and a gateway sits at the front of the system to route requests from users to the right services. Netflix used this approach to rebuild a system that was destroyed by a 3-day outage into a platform that serves hundreds of millions of people across the globe. Amazon used it to create an engineering culture that can ship thousands of updates every day. Uber used it to scale a startup application into a global platform operating across hundreds of cities simultaneously. The benefits are clear: independent scaling, fault isolation, faster development, technology flexibility, and team autonomy. The challenges are real: greater complexity, communication overhead, data consistency, and the need for mature tooling and processes. And the right time to use it is when your application, your team, and your business are genuinely ready for it. Microservices is not a magic solution. It is a deliberate architectural choice, one that, when applied with care and judgment, can give a product the resilience and flexibility to grow without limits. Thank you for watching. If this video helped you understand microservices architecture more clearly, please share it with someone who would benefit from it. And if you have not already watched our video on the strangler fig pattern, the most common way companies migrate from a monolith to microservices, that video is linked right here. Until next time, keep learning, keep building, and keep asking great questions.